Okay, we're going to start today applications of two variable systems. And with this, you've been solving two variable systems, so this is just taking these and setting up the equations. So this won't be a very long lesson, and you should have a lot of practice with this by now. On this first example, you have 8 pens, 7 markers cost $3.37. 5 pens and 11 markers cost $3.10. Okay, write a system of equations to find the cost of each pen and each marker. State how you would solve the system, meaning substitution or elimination. Okay, we need to find variables. What you're going to do is you're going to write something like P is equal to the number of pens. Okay, and M is equal to the number of markers. Okay, and then you'll go over here and write one equation. Well, one equation is that 8 times the cost of a pen plus 7 times the cost of a marker is going to equal $3.37. And the other equation would be 5 pens plus 11 markers is equal to $3.10. And the easiest way to solve this, since all of these have coefficients in front of them, should be elimination. And unless it tells you to solve, this is all you have to do. Write a system to solve each problem. And state how you would solve it. So you just need to write these two equations. In example 2, you have movie theater tickets. You have regular tickets. The number of regular tickets. And Y will be the number of senior tickets. Okay. Okay, so regular tickets are $8. Senior tickets are $6. Okay. One evening, the theater sold 525 tickets. So altogether, X plus Y are equal to 525. And the next one's going to have to deal with how much money they made. They made $8 for every regular ticket, plus $6 for every senior ticket, and the total amount they sold was $3,580. So you're always in this type of question, you're going to have one equation that deals with how many there were, and the other one that deals with the money. Since you have some of these variables that have just one as a coefficient, this one could be solved either way, by substitution or elimination. Doesn't really matter which one. All right, now let's look at example 3. Go down. I'm going to have to go, and I'm going to take the mouse so I can go down. No, why is it not letting me go to the next page? There it goes. Okay. All right, so you have a delivery van, has a fixed charge for the first mile of travel, and charge per mile for each additional mile. So X is your fixed charge. Okay, and Y is the dollar per additional mile. Okay. So a delivery van has a fixed charge for the first mile of travel, and the charge for each additional mile. A 6-mile trip is $6.90. So you have your fixed charge. plus 6 miles times the charge per mile is going to be $6.90. And then you have, oh, well, this is a mistake. It's for each additional mile, so instead of 6, the first mile is X. So we need to change that. That's where an easy way to make a mistake. We need to change that to 5, because there's the first mile is X, and then there's 5 more miles for a total of 6-mile trip. So for the 11-mile trip, we'll have our X for our first mile plus 10 additional miles times Y is going to equal $11.40. And we could do this either way because we have x's there with coefficients of 1. So we're going to say it could be substitution or elimination. Okay. All right, now for example 4, Jack has $3 in nickels and dimes, and he has twice as many nickels as he does dimes. So we have N is the number of nickels, and D is equal to the number of dimes. Okay. And one equation is that 0.05 nickels, so each nickel is worth 5 cents, plus 0.10 or 10 cents for every dime is equal to $3. Okay. Now, if you wanted to eliminate the decimals here, you could say 5m plus 10d equals 300. You can do that if you don't want to use the decimals. And he has twice as many nickels as he does dimes. So if he has 1 dime, he has 2 nickels. So nickels is equal to 2d. This is one of those equations you have to kind of say to yourself and use a couple numbers to be sure you have it right. And this method, I think, would be better since you already have n equals, and that should be an n, not an m. Okay, since you always have a value for n, you could substitute the 2d in there. So this would be much easier just to use substitution. Than anything else. Now on this next one, we have the difference of two numbers is 2, and the sum of their squares is 10. So we'll just say x is the first number, and y is the second number. Okay. Difference means we're going to subtract, so x minus y equals 2. Okay. And the sum of their squares, so that means you've got to square them. X squared plus y squared is 10. So you've got to square both of them and find the numbers. And again, since we have coefficients of 1, this could easily be solved by substitution or elimination. Okay. So that's the end of this section where you just find the equations and tell me which way you want to solve them. Pretty straightforward, shouldn't be too much trouble. The next little section, we're going to go to talk about supply and demand. And y'all have or know what supply and demand is, but I'll just go over it. If a store or supplier, merchant of some kind is selling some quantity of merchandise, what he has to sell is called the supply. And what he has available can be affected by a lot of things. Examples here are storage space, how fast he can manufacture these items, general availability of product of one of the maybe raw materials from the merchant supplier. Different things can affect that supply. What he has that the customers want is called the demand. And price can affect demand, obviously. A lower price tends to make consumers buy more, and a higher price tends to make them buy less. when you have a lot more supply than you have demand, then it's obvious the merchant suffers because he doesn't sell all his stuff. He gets a lot stockpiled in storage, or something happen. He just doesn't. He's not selling what he needs to sell. Sometimes though, when demand is too great, that can be a problem too, because people may leave him. They may not come back. They may go someplace else for their business. So ideally, the merchant wants that supply and demand to be in equilibrium, or where he has basically just about as much supply as he has demand, where they're essentially equal. And so our last example has to do with the supply and demand problem. Sarah Wentz, the marketing director for Console Concessions restaurant chain, she has decided to have a cartoon character doll made to sell at premium price at participating locations. The company can choose from several different versions of the doll that sell at different prices. Her problem is to decide which selling price will best suit the needs of Console Concessions customers and store managers. And she has some data that's listed in this table. It is dollar. This is from previous promotions. They supplied 35 to the store. The number requested per week per store was 530, and you can read the rest. So it says use the points given to find the equation for supply as a function of price. So we're going to look at we're going to have to figure out a slope and y-intercept here, and as a function of price. So this is going to be your x. Okay, so let me get this up here. Here we go. This is going to be x, this is going to be y, and this first, or this is going to be s, and this is going to be x, and this will be demand. Okay. Now, if we look here and get that difference, the way you're going to find slope, we have 135 minus, 130 minus 35, and that's 95. Okay, so this difference here is 95, and obviously this difference is 1. This difference is 2, and this difference is 320 minus 130, and if I divide that by, so that's 190 here, and if I get the slope by dividing 95 by 1 and 190 by 2, that's consistent, so the slope is 95. So the slope here, between here and here, m is 95. Okay, 95 over 1, 190 over 2. Now I have to figure out what it would take to make my rule, like we've done in many cases in the past. So I know I have S equals 95 times X, and I have to figure out 95 times this minus some number will give me this number. So 95 times 1 minus 35, that would be 95 minus 60, would give me the 35. Now let's do 95 times 2 minus 60 and see if we get 130. So we have 95 times 2, and then minus 60, and we do get 130. And you could check it again and find that your rule holds true. So this is the equation that makes the equation for supply as a function of price. Now we're going to do the same thing for demand, okay? Now this goes down by 130, so it's negative 130 over 1. So I think it's going to be D is equal to negative 130x, but let's check this one and make sure it's constant. 400 minus 140 goes down minus 260, and you divide that by 2 and you do get 130 again. So we're good on that. Okay, so now 130 times 1, negative 130 times 1 What do we have to add to it to get there? Well, it's going to be plus 660. Okay, well, so let's try that again. Let's do the negative 130 times 2, and that gives me negative 260. If I add 660 to that, I get to 400. So, and I can check it again with the 4 in for the x and make sure I get to 140. But this is the equation that's going to get me to this. Now, what I want to do to these two equations, it says use the graphing calculator, find the exact price. So what you want to do is go to y equals, clear it out, and put 95x minus 60 in y1, and put negative 130x plus 660 in y2, and graph it. And you might have to do zoom, might have to do a zoom fit, which is zoom 10. And you should see both of your lines. And then you want to see if you can go to the table, okay, and find a value where the price is in equilibrium. Okay, so what you want is, what we're going to do is we're going to have to change our table set. You can do we're going to do a table set, a delta table. Do that at 0.1. We go second table set, and then change the delta table to 0.1. Then when you look at the table, okay, and you're going to look where y1 equals y2, and it's going to happen if you go on up and look in your table at $3.20. At $3, and you should be able to also solve this for, set this equal to this and solve for x is what you want to do. So you could do it mathematically. You could say 95x minus 60 equals negative 130x plus 660 and solve it for x. But that on your calculator, you look for where the y1 and the y2 are the same, and that's $3.20. Okay? And we notice that at that, the y's are 244. You would supply 244, and hopefully the number requested by the store would be 244. Okay, so now we're going to go down to the next questions, and I'm going to have to try to move this up. So let me go back to my mouse and see what I might have to go off full screen mode. Let's go off of this. Is it going to let me? No. Let's see, okay. There it goes. Okay, we're going to go off full screen mode, and we're going to come over to example 6, and I want to pull it down to the bottom so I can answer these two questions. And for these two questions, I need to move this over. You need to look at your calculator again if you have it. If Wendy sets the price at $250 per doll, how many disappointed customers will they have for the week? So let's make a little table. We've got the price, okay, and you've got the supply, and you've got your demand, and we're going to use those two equations, okay? So at 250, you go up to the top and you have the 95x minus 60. You put in 250 for that x, so you have 95 times 250, and then minus 60, and so that's 177.5. Okay, and demand at 250, and again we're working with the equation negative 130 x plus 660. Okay, so you put in the negative 130 times 250 plus 660, and the demand is 335. Okay, we only have 177 and a half. So you figure out 335 minus 177.5, and so what you end up with is one. How many disappointed customers are you going to have? Well, you had this many to sell. Your demand was 335. So that comes out to 157.5. Well, can't give a half of one, so you're going to have 158 disappointed customers that you didn't have enough. Okay. So you were short that many dolls. If she sets the price at $380 per doll and not doll, okay, you do the same thing down here. Okay, you're going to take $380, and in putting that in this equation, you should end up with $301. And here the demand is $166, so she ends up with a surplus here in this one, and of $135. 301 minus 166 is 135. How many unsold dolls? So it's 135 unsold dolls because she has a lot of supply and not as much demand. And so that's one of the ways to sort of figure out how what she's looking for, where would be, how many she needs to get. And so this is just an example of a type of problem you could use two systems to solve. Okay.